Hey there, myself is Kaushik and today I'll be demonstrating Arduino project to find object speed. I'm on TinkerCad website. So first of all, I'll be showing you how this circuit works and then later I'll be telling you the principle behind it, what I have used, and then I'll be showing you the circuit design, and then later I'll be showing you the code part which I have written. So first of all, let me show it how it works. So yeah, as you can see, on the left hand side, there's an object kept in front of the sensor, and on the right hand side, I am displaying the distance of the object and the speed with which the object is coming towards the sensor. So yeah, first of all, let me show you how it works when I deflect the object. I'm moving the object towards the sensor, and as you can see, the speed of the object is being increased. And as I am moving the object backward, the speed is becoming negative. Let me do it like this. So here, as you can see, the object's distance is being shown and the current speed is being shown in centimeters per second. Now I will tell you the principle behind it, what I have used. As you can see on the right hand side, I have calculated the distance twice, and then I have found the speed here. So first of all, let's say at time t equals to 0, my object is here, and now after some time interval, the object is has moved backwards. Now I had calculated the distance of the object previously, and now I have the distance of the object from it now, and I also know the time interval during which this change has happened. So the distance, the difference of the distance divided by time has given me the speed. Now let's come on to the circuit design part which I have made. I have used Arduino Uno, a breadboard, and an ultrasonic distance sensor. I have connected the 5-volt pin of the Arduino to the positive terminal of breadboard and the ground pin of the Arduino to the negative terminal of the breadboard. Now coming on to the ultrasonic distance sensor, it has 4 pins. The first is for VCC, that is the power input. The second is for trigger. Trigger produces sound pulse which is received by the object, and when the object reflects the sound pulse, it is the ultrasonic distance receives the sound pulse through the echo pin. And the fourth is for ground pin to complete the connection. Now coming on to this left hand side part, I have connected the fifth port of Arduino to the trigger pin of the sensor, and the sixth port of the Arduino to the echo pin of the sensor. Now let's come to the coding part which I have done. First of all, I have declared two variables named trigger pin and echo pin. I have set the trigger pin variable to 5 and echo pin variable to 6 because the trigger because it is connected to the fifth port of the Arduino, and echo pin is connected to the sixth port of Arduino. Now I have declared a variable named duration. It will be storing the time duration between the sending and receiving pulse. First distance and second distance to calculate the first and second distance respectively. Speed variable which will be calculating the speed of the object. Distance variable, it is a temporary variable which I will be using to find the distance. Time variable, it is the time where it will be storing the time delay in seconds between the first and second distance. You can actually change this time variable as per your resolution of the sensor. I have taken it as 1 second. Now delay time, it is the time in my milliseconds. In the void setup function, first of all, I have written serial.begin 9600. It is used to establish serial connection so that output could be sent from the Arduino. It is now the second line is for the trigger pin, which will be used as output to send pulse. The third line is the echo pin, which will be used as input to receive the reflected pulse. Now in the void loop function, I have called the getSpeed function. Now let's see what the getSpeed function is doing. So yeah, here it is first of all calculating the first distance using the getDistance function. I'll be telling you about the getDistance function later. Now delay, I have produced a delay of the delay time as which I have already told before for 1 second. Now the second distance variable will be storing the second distance using the getDistance function. Now I have simply taken the speed as first distance minus second distance divided by time. Now I am printing the speed here. So now let's come to the getDistance function, how it is finding the distance. First of all, I have set the trigger pin to low and produced a 2 microsecond delay so that the trigger pulse could be actually the trigger pulse will be cleared so that the trigger pulse which was coming before will be destroyed so that it may not interfere between the current calculations. Now I am setting the trigger pin to high, which will be sending the pulse, and I'll do this for 10 microseconds and then I'll stop the trigger pulse. Now I'll be calculating the duration using the pulse in function. So here I have calculated the distance using the formula speed into time, and I have divided it by 2 because the trigger as the distance will be twice, because first of all it will move to the object and then it will come from the object to the sensor, so that the distance will be twice, but I want the half of this distance, that is the distance between object and the sensor. Now this duration as already calculated here, it is in uh, like milliseconds. Now I have multiplied it with the speed of the sound in the duration is in microseconds, and I have multiplied it with the speed of the sound in microseconds. The speed of the sound is 340 meters per second. I have multiplied it with the duration, which is 0.034. Now I'll print the distance in centimeter and return this distance variable. So yeah, this was the coding part. So I hope you understood this video. Thanks for watching.